So today we're going to do a quick lesson on how to solve a system of equations using substitution method. There's two main choices, substitution method or elimination method, and we're going to start off today with substitution method. So we're going to need two equations. So we're going to have 3x plus 2y equals 21, and we're going to have 2x plus y equals 13. So there are two equations with two unknowns. We've got an x, we've got a y. First thing I want to remind is that even though there's no coefficient listed here, there's really an actual coefficient of 1. You can go ahead and put it in if you want, or you can leave it bare, but it's always good to remember that if there's no coefficient provided, it's really a coefficient of 1. So I'm going to put that there just so that we don't forget. So when we're thinking about substitution method, what we're going to always have is there's always going to likely be a variable that's kind of easy to get at. Otherwise, we're probably going to use elimination method. So to kind of as a qualifier for using substitution method, we always want to have a variable that has a coefficient of 1. It can either be positive or negative. As long as it's got a coefficient of 1, it's a pretty darn good candidate for actually being a system of equations where you'd use substitution method. So in this case, I've got this coefficient of 1 on the y in the second equation. So the first thing that you're going to do after you've identified that this is a good candidate, and it is we are going to take and we're going to isolate for that particular variable, meaning we're going to get it all by itself. So we could start by taking the second equation and subtracting 2x from both sides, which is going to end up looking like y equals 13 minus 2x. So we've isolated this variable to be all by itself, and this is what it represents. So this is the second equation. So this is equation number 2 that we're working with. We've got equation 1 and we've got equation 2. So after you have isolated the variable that you're looking for, what we're going to do is we're going to really carefully substitute it, hence the name of the method, into the equation that we didn't rearrange. So because we didn't rearrange equation number 1, we're going to substitute this into equation number 1. What that's going to look like is we're going to take and we're going to say, all right, 3x, that's not changing at all, plus 2. Now, this is 2y, and we have solved for y. So what we're going to do is we're going to substitute this set of values in for that y value. So I'm going to replace that y with a set of brackets, and we're going to substitute this information in here. So we're going to have 13 minus 2x. And so I've gone ahead and I've substituted in here 3x plus 2y equals 21. So I still need my equals 21. So let's kind of revisit what we've done here. We've isolated for a variable. We're always going to do that in substitution method. We're going to make sure that we substitute into the other equation that we didn't rearrange, which we've done. And now we're down to having an equation that's only got one type of variable in it. Notice, even though there's two variables, they're both x's. So we're going to use that and we're going to distribute and we're going to solve what's left in this equation for the value that we're looking for. So we're going to have 3x plus 2 times 13 is 26. 2 times negative 2x is negative 4x equals 21. So we're going to gather up our like terms. So we're going to have 3x minus 4x. So 3x minus 4x is negative 1x. And I'm going to move the 26 over. So it's going to become 21 minus 26. What we really did is we subtracted 26 from both sides, but to expedite it, I just moved it to the other side. So I've got negative 1x equals 21 minus 26 is negative 5. So we're really close to where we need to be, but I don't want negative 1x, I want x. So I'm going to divide both sides by negative 1, divide by negative 1, and we're going to get that x equals 5. Excellent. So we now have a value. We've got x equals 5. My apologies. So there we go. We've got x equals 5. And so we're a long ways there. Now, this is where a lot of students will make a mistake. They'll think, haha, I've got an answer. I'm all done. But in fact, we only have one of the values. Not only do we need a value for x, but we need a value for y as well. So I know what my x value is. So I'm going to take that x value and I'm going to substitute it back into one of my original equations. You know what? It doesn't actually really matter. I'll substitute it into the first one. So we're going to have 3. And now we know what our x value is. Our x value is actually 5. So I can go ahead and I can put an x value of 5 in. So anytime we do a substitution, it's a good idea to put it inside brackets. So we're going to have 3 times 5 plus 2y equals 21. Now, good position again, because look, we've got an equation. We only have one unknown. So we're going to take that one unknown and we're going to solve for it. 3 times 5 is 15 plus 2y equals 21. I'm going to subtract 15 from both sides, which is going to give us 2y equals 21 minus 15, which is going to be 2y equals 21 minus 15 is, of course, 6. Divide both sides by 2, divide by 2, and we're going to get that y equals 3. So we contend that the answer to this problem is xy is equal to 5, 3. Now, if we are in a hurry, we can just assume that we made no mistakes, but it's not a bad idea to actually go ahead and perform a check. So I'm going to really quickly do a check here. Now, with the check, what we're going to do is we're going to take the equation that we didn't substitute into. So we substituted into equation 1 up here. So, right there, that was equation 1 that we used. That means I'm going to use equation 2 for my check. So equation 2 says that, well, it says that 2x plus 1y, or plus y, equals 13. Well, we're going to do a check. We're going to try and keep things formal. So we're going to separate into left side equals and right side equals. So the left side is everything to the left of the equal sign. So there's 2x plus y. And the right side is, of course, everything to the right of the equal sign, which is 13. So now we contend that x and y are 5 and 3 respectively. So I'm going to say, all right, let's check that. So we're going to have 2 and x is 5, again, substituting into brackets. And y, well, y is 3. Here we go, substitute into brackets again. And I can simplify that. 2 times 5 is 10. 3 is still just 3. 10 plus 3 is 13. And so look what we've got. We've got that the left side, in fact, equals the right side. So we can have a great deal of confidence that, in fact, that we have the right answer. So the right answer is going to be xy equals 5, 3. So that's substitution method. Again, it's useful when we have an equation that has a single coefficient of 1 or -1. And in that case, we can isolate, substitute, and solve. Okay, great.